go through an example of how to perform a t-test for a sample mean. So the survey of study habits and attitudes is a psychological test with scores that range from 0 to 200. The mean score for U.S. college students is 115. A teacher suspects that older students have better attitudes towards school. So she gives the test to a simple random sample of 45 students from the more than 1,000 students at her college who are at least 30 years old. The teacher wants to perform a test at the 0.05 significance level. So this is broken down into 4 parts, which correspond to our 4-step process. First, we have the state, we have the plan, we have the do, and we have the conclude. Of course, the null and alternative hypothesis, typically when we're doing a 4-step process, won't go right here, but it is broken down in 4 different sections, so I think it's an effective way for this problem. So first, what are the null and alternative hypotheses for the significance test? So we know for the null and alternative hypothesis, we're making predictions about the population mean, right? And the population is older college students, right? Students who are 30 years old or more. We know the null hypothesis should be that the population mean equals a number, and in this case, whatever that number is, the population mean, or for the alternative hypothesis, is either greater than, less than, or just not equal to. So in this case, it says that we don't know. So that the mean score should be 115, and since this teacher thinks that her older students have better attitudes, then that would suggest that the alternative hypothesis is that the score would be above 115. So if we're going to state this like we would in a proper free response setting, we would like to test to see if... There you go. Now, have the conditions for a test like this been met? Well, what are those conditions? First, there has to be randomness in the selection of the sample, or it has to be from a well-designed experiment. And in this case, we do see that it is a simple random sample of 45 students. The next condition is that there has to be at least 10%, the sample has to be less than or equal to 10% of the population. 45 is, in fact, less than 10% of 1,000, right? And then, of course, the large counts rule. Remember from the notes, it said our sample size has to be either greater than 30 or it has to come from a normal distribution, or the population distribution has to be approximately normal, or we have to perform some sort of test to check to make sure. In this case, 45 is bigger than 30, so 45 is bigger than 30. So the central limit theorem apply here. Now, and if we are going to answer this as part of the 4-step process, we would sort of suggest, or we would sort of say what we've already set up above. And there we go. So now the next part, it says that the teacher went ahead and performed the test and found that her simple random sample of older students had an average score of 125.7 with a standard deviation of 29.8. So in this, we're going to assume that we're using a calculator like we should. So we're going to perform the one sample t-test here in the calculator. So menu, statistics, stat tests, t-test. We have the actual statistics. The null hypothesis was that it was 115. The sample mean was 125.7. The sample standard deviation was 29.8. The sample size was 45, and we are checking to see if the mean is actually bigger than our hypothesized mean. All right? So it gives us a test statistic, a t-score of 2.4, which has a corresponding p-value of 0.1, or 0.01, sorry. and of course to interpret that, and there you go for that. So we're done with the calculations. Now, based on this information, what conclusions can we draw? Well, our significance level was 0.05, so all we have to do here is say, okay, well, is this less than our significance level? And of course it is. So since 0.01, since we're rejecting the null hypothesis, that means we do have evidence to support the alternative, and the alternative we should always put within context of the problem. So, and there you go. That is how you would perform this one sample t-test.